All right, so we're going to try this one more time. I'm going to run everything back for a second take. Yeah. We're going to try the grouping method one more time. So, a couple things to know about the grouping method. We must have 4 or 6 terms. We cannot use the grouping method if you have 3 terms. You cannot use the grouping method if you have 5. You can only use the grouping method if we have 4 or 6 terms. So we're going to look at some problems later on using the grouping method. And we're going to know we can use it as soon as we see 4 terms or 6 terms. So let's go over the steps of grouping. Our first step tells us to group, which is just parentheses, around the first 2 terms. The first 2 terms. And then we must group, which is parentheses, around the second 2 terms. Once we've finished grouping, we must find our GCF of each group individually. So you will only just be looking into the groups for the GCF. You won't be looking at the entire polynomial. Once you find the GCF, of course you will pull out GCFs. And we should have the same thing inside the parentheses, or should I say each parentheses. Once you see the same thing in each parentheses, you know you've done it correctly. And then you take the final step, which is just to write what's on the inside and write what's on the outside. Remember that you cannot complete factoring by grouping until you have completed this step, which means we can't stop after we've just found the GCFs and pulled them out. We can only stop after we have written what was on the inside and write what's on the outside. So let's do an example problem so we can see this in action. There's a lot of noise out there. So be quiet, down. All right. Here's an example of a problem that we can use grouping. All right, on this problem, first thing we've noticed is that we have 4 terms. So this has 4 terms. Well, that meets the criteria that we must have in order to use grouping. So we're happy there. So we know we can use that tool. Of course, the first thing we do when we look at polynomials is there a GCF in the entire polynomial? Looking here, I don't see a number that can go into 8, 64, 1, and negative 8 evenly. And I also don't see a constant variable in all terms. Because this variable does not even have, this term does not even have variables. Therefore, we must use our grouping method to factor. Step 1, we must group the first 2 terms. So I'm just literally putting parentheses around the first 2 terms. As a matter of fact, to highlight this, I'll use different colors. So that would be the grouping of the first 2 terms. And then we must group the second 2 terms. Here we can see the first 2 terms being grouped, and then the second 2 terms being grouped. So it's looking good so far. Our next step is to find the GCF of each group individually. So we're just looking at this group first and looking for a GCF of just this group. You should notice that an 8 can go into both. So an 8 should come out. Now we're looking at the variables, which is r. We notice that there's an r in both of them. So now we must choose the one with the smallest exponent. That would be r squared. So we'll take out an r squared. Once you found your GCF, remember to divide each term by the GCF. So we're dividing each term, let's do that in a different color, by our GCF. This is what's going to tell us what goes back into our parentheses. Dividing 8 by 8, of course we get 1. Dividing r cubed by r squared, you're left with just r. Dividing 64 by 8, you're left with 8. And r squared divided by r squared is 1, but 8 times 1 is just 8, so we don't write it. Good so far. Here we have r minus 8. Now this can seem a little confusing because there's no number that can go into 1 and a negative 8 except 1. So when we have no number except 1 using the grouping method, I'll just write down 1. Well, this doesn't change anything on the inside because r being divided by 1, well, that's just r. And negative 8 being divided by 1 is just negative 8. Now, the reason I wrote down 1 is so you can see the number there. This helps us in the final steps. Here we're able to see, well, they look the same, so we're doing things correctly. That's the step that lets us know if things are going well. And the final step that we cannot forget is to write down what's on the inside, followed by what's on the outside. That would be the completed factored form of your four-term polynomial. Let's try one more. Let's do it over here. Ooh, might run out of space. Let's give it a try anyway. Let's do, well, no, let's go over here. Let's do another one. Let's do 12p cubed minus 21p squared plus 28p minus 49. First thing I notice, 4 terms, meets our criteria. Looking good so far. Of course, we always must look for a GCF first, so we're trying to find a number that can go into every one of these. And I cannot find a number that can go into 12, 21, 28, and 49. So now I go into my next tool, which is grouping. First things first, let's group the first 2 terms. And then we must group the second 2 terms. Good so far. Find our GCFs of each group individually, so it's just this group now. Trying to find a number that can go into 12 and 21. If you're thinking 3, sounds good to me. I'm a rapper. I know. And then we're looking at our P's, and we're choosing the smallest exponent. Be sure to take your greatest common factor and divide each term by it. So if I take 12p cubed and divide it by 3p squared, I'm left with a 4p. And then our negative 21p squared divided by 3p squared leaves me with just 7. That completes the first group. Now we must do the second group. Here we'll be able to see that our GCF here is 7. Dividing our GCF back into each term, we're able to see how we get 4p minus 7. We know we're doing good. Both of our insides look the same. So we get to our final step of writing what's on the inside and writing what's on the outside. So we have the inside, which is 4p minus 7. And then the outside, which is 3p squared plus 7. That's our completed form. Now you guys will practice a few problems on your own. You may review this video if you need more help. Good luck.